So today we'll be talking about one of the last or the third pillar of object-oriented programming. We've discussed the other two. So inheritance, encapsulation. Encapsulation, if you remember, that's when we have our classes and we use private variables within our classes and we access those and modify those using public getters and setters. Inheritance is where one class can inherit all of the attributes and methods from another class. So today we'll be talking about polymorphism. And polymorphism, and that's what we're talking about today. The last one would be abstraction. We'll talk about that a little bit later. Polymorphism allows us to use a subclass in place of a superclass, right? So for example, let's say a method, it only accepts, if we think back to our animal example, right? A method only accepts an animal object. Well, since cat and dog are a type of animal, that method would also accept a cat or dog, right? Same thing, we can declare an animal, but create a dog from that variable. And I'll go through all of these examples that I'm talking about in the code. Similarly, inside of our cat, dog, and mammal, fish classes, we can override methods or overload methods that were declared in our superclass, in our animal class. So for example, what I was doing earlier was that in my animal class, I created a toString and it just prints out the sex of the animal, all right? But because of polymorphism, I can override that toString in all of my other all my other classes that inherit from animal. So you see mammal overrides the toString method. Dog overrides the toString. Dog inherits, extends mammal. Right? So therefore it's overriding the mammal toString method. So on and so forth. All of these ones inherit from, a successfully higher type of animal. Whereas fish inherits directly from animal, mammal inherits from animal, and cat inherits from mammal, right? So this is what we did, I believe, 2 classes ago when we talked about the animals and we had the different hierarchy of types of animals, where animal was at the top, then it separated into fish and mammal. And then from there, mammal, you had 2 types. You had cat and dog. All right. So again, polymorphism allows us to override those methods in our subclasses. We can also declare a superclass object. So I can create an animal object, then instantiate it as a subclass. So by that I mean, if I go to my main, I can create animal A, right? I can just declare that variable. From there, I can set animal A, let's do user input. So scanner input equals new scanner system.in, import the scanner object, then prompt the user system.out.println. Enter, actually, which type of animal would you like to create? Right? I'm just asking them what type of animal would they like to create. And here, up here, I have 1, 2, 3, 4, 5 types of animals. Right? I have a generic animal, cat, dog, mammal, and fish. So let's give them those options. System.out.println, 0 for animal. Let's say basic animal. Basic animal. System.out.println, 1 for fish. So I'm just prompting the user to type in something for the type of animal they want to print. 2 for mammal, system.out.println, 3 for cat, and then lastly 4 for a dog, right? So the user can choose which one they want to make. Okay, so they can either make a basic animal, a fish, a mammal, a cat, or a dog. Okay. So then I'm going to switch. Actually, I'm going to read that in. Int option equals input.nextInt. I'm going to read that option in from the console. Then I'm going to switch on it. Right? I'm just going to do a basic switch statement. So case 0, and this is what I'm talking about. So I can say I declared animal up here, animal A. I can say A equals, remember case 0 means they want to make a basic animal. So I'm just going to create a basic animal. Did I spell it wrong? Animal. Why is it not working? Am I spelling it wrong? Hold on. Just make sure everything is right. Everything is right. Oh, new animal, sorry. A equals new animal, right? That was the basic type of animal. However, let's say they want to create a fish. I can also say A equals new fish, right? I can do that because of polymorphism. Because fish is a subclass of animal, I can create something more specific, right? I can create a fish, even though technically A is an animal. But since fish inherits from that, I can create a fish because every fish is a type of animal. However, I cannot do the inverse. I cannot create a fish up here and try to set that equal to new animal because every animal is not a fish, right? There's many types of animals. So I can't just say fish A equals new animal. That won't work. However, I can do animal A equals new fish because, again, fish inherits from animal. Every single fish is a type of animal, but not the other way around. So even though I create new fish down here, it's a type of animal. So I can set animal A equals to new fish. And you can do the same thing for all of these. Case 2, A equals new mammal, break. Case 3, A equals new cat. Again, all of these types of I want to say classes, these classes inherit from animals. So I can create these subclasses of animal. New dog. Break. All right. Fish inherits from animal. Mammal inherits from animal. Cat inherits from mammal, which by extension inherits from animal. Dog inherits from mammal, which again by extension inherits from animal. So again, going all the way down the line, you can declare a general type of object, animal. And then actually when you instantiate it or create the object, it can be of any subclass of that, right? Because any subclass is a type of that superclass. So all these dogs, cats, mammals, fish, they are a type of animal. So I can declare animal, then create a subclass object. Does that make sense? You shake your head up and down or side to side.
Sir.
Does that make sense to everybody? Or should I go through it again? All All right, I'm gonna keep going then. All right. So again, just to reiterate, since fish is a type of animal, I can create a new fish object even though I declared this as an animal. Okay. Same with mammal, cat, and dog. So it's kind of helpful in this situation, right? Because now I can just create the basic animal object, and then from there, set it equal to whatever type that person is going to create. Okay. So you think back to our geometric object and circle, same thing. I could create a basic geometric object up here, and then depending on the user input, create either a geometric object or a circle. Okay. This is really helpful if I want to use this object outside of the switch statement, right? Because I could just as easily say fish f equals new fish, but I can't use f down here. F dot toString. I'm going to get an error. There is no f. I could declare fish f up here, and I could do mammal m, cat c, and dog d. Then I could use f dot toString, but depending on the user input, by me just saying f dot toString, what if they put in a mammal? There still would not be an f. And look, even it's saying, I believe is the error is that it won't work because it may not be initialized, right? A user may put in a 4, which means that they're trying to create a dog. So f was never created. So that's what this error is. So instead of doing this, I could just have the basic animal, delete all this, a equals new fish, and down here I can say a dot toString. Regardless of whatever they create, I think this one is going to say it. Yeah. So let's just create a default statement. A equals new animal. That's in case they didn't type in the right number. So regardless, I can use a.toString, and it doesn't matter what type of animal I created, it's always going to call that toString from the object. Every single one of those types of objects has a toString, so it'll work. Okay. On Monday, we'll talk about how to check what type of animal it is, but we'll get to that on Monday. Right. So again, we can declare a superclass object, then instantiate it as a subclass, which is what we did. We created an animal, we declared it as animal, instantiated a cat, instantiated a dog. Right. And this is what I just did right here. Since we know every cat or dog is an animal, we can declare a variable as an animal, then depending on user input, create a cat or a dog object. That's what I just did. I also created either a fish or a mammal. So any of those are possible. We can also declare methods with superclass parameters, but pass a subclass. So if we think back to our animal, cat, dog example, if every cat or dog is an animal, any method that accepts an animal as a parameter will also accept a cat or a dog. Okay. So if we think back here, let's do a public void, public static void display info, animal, right? So I have this method, and basically all I want this method to do is call the toString method, right? So all I'm going to do is system.out.println animal.toString. Okay. So of course up here I can call display info, passing in our variable a. I can do that. I can also do fish f equals new fish, and then call display info, passing an f, right? Again, since f is a subclass of animal, I can pass that to this variable, to this method, and the method will still work. It's expecting an animal. Since every fish is a type of animal, this method still works, right? I can pass in a fish to this method and it will still work. So let's run this example. So again, the first thing it's going to ask is what type I want to create. Then based on what I type in, it's going to create that. Lastly, it's creating a fish, passing that fish. All right. So let's run this. What type of animal? So let's say I want to create a mammal. So the first thing is it created the mammal. And actually, let me put a space in between there. All right, let me run this again. Let me create a mammal. So the first time we call that method, it says sex is female, mammal, bipedal, and quadrupedal. So that is the toString method of our mammal class, right? Our toString for our mammal does all this. It returns this string. First, it's calling the animal toString method. Then it's concatenating in this information, whether it's a mammal, if it's bipedal, or quadrupedal, okay? Our fish toString method, again, calls our animal toString, then says it's a fish, and whatever species it is, then the number of fins. And that's what we got right here. So the first time we call display info, I create a mammal. So A is a mammal. It passes A down to display info. Then it prints it out. And actually, let's debug this so you can see what I'm talking about. Line by line. So I'm debugging this. Again, I want to create a mammal. All right. So you see down here, it's kind of small, but A is a type mammal. All right. That's what we said. We wanted to create a mammal, and we did. A equals mammal. So now when I call display info passing in A, it's going to display that mammal toString. Then we got another system.out. Next, we want to create a fish. That's what we did, F. F is a fish. Okay. Then we call the display info method on F. And it prints that out as well. Then we finish. So again, polymorphism allows us to be creative with how we want to declare our objects. So I declared an animal way up here at the top, animal A, but based on user input, A can equal any type of animal, either a fish, a mammal, a cat, or a dog. But when I create methods and stuff like that, I can expect a superclass object, but any subclass will fit in there as well because they inherit that superclass. They inherit every attribute from that superclass, so it still works, right? I can still call animal.toString down here, and it still works. So let's do this all in a loop so we can see this over and over again, what happens. So while option doesn't equal -1. So if I want to end, I'll put a -1 in. All right. And I got declare option, and option equals let's just say 0 by default. Then we read in a new option here. All right, so if I run this, it should let me keep generating animals over and over and over again until I enter a -1. So what type of animal? I'm going to say a dog. And you see down here, it prints out all of the dog's information. So the first one it calls is the animal toString, which prints that out. Then it calls the mammal toString, which prints this out. And then lastly, the dog toString right here. Okay. And I am, in fact, calling my method display info. Again, polymorphism allows me to pass in a subclass of animal and print out that information or manipulate it as if it's an animal. All right. So let's create another type of animal. Let's create a fish. That works as well. It calls the animal toString and then the fish. If I create a cat, again, animal, mammal, cat. If I create a basic animal, the only thing in that toString is the female, is the sex, I'm sorry. If I create a mammal, you have the sex and then some more information regarding a mammal. I have the dog. You have the sex, the mammal again, and then the dog. So again, polymorphism, it allows you to manipulate the relationship, the superclass, subclass relationship, and have methods that adjust to that, or declare your objects based on whatever you have. So what if it's not user input? What if you want to randomly generate an animal? I can do that as well, right? I can randomly generate any type of animal, then pass it to a method that expects an animal, okay? Mammals, cats, dogs, fish, they're all types of animals. So as a result, you can call those methods. So I have a little bit more real world example that's not really programming related, but hopefully it puts it in a little bit more perspective of how polymorphism works, how the superclass subclass relationship works. So for this example, let's say we have a security system, all right? This security system, you have to provide a drop of blood in order to access the contents inside a vault, okay? So it's highly secure and pretty invasive security system. All right, so the only person who's authenticated with their blood is Sean. However, for whatever reason, Sean is not available. So his daughter, Renee, her biometric information works as well because Sean passed down all of his DNA to Renee. Okay. Flip side of it is, if this system is only authenticated for Renee, Sean's DNA wouldn't work because he only has half of Renee's, right? Her mother has the other half. So we look at the relationship. So here's the biometric vault, right? Sean's DNA works. By extension, Renee's works because she inherited all of Sean's, right? So it works all the way through. Since Renee inherited all of Sean's DNA, she has the correct markers in her DNA to work for this system. On the flip side, however, this does not work. Because Sean only has half of Renee's DNA, he can't get into this vault, right? You would have to have somebody that has all of Renee's DNA to get into this vault. So if you think back to programming, this biometric vault would be like a method, okay? Our method accepts Sean's markers, right? Sean's DNA, whatever. So any child of Sean would work in that method. okay? So if you think back to our animal, our method only accepts an animal. But any subclass of animal, so mammal, cat, dog, fish, it works by extension in that method. However, if we have this relationship, let's say our method only works for a dog. We cannot pass in an animal to that method because animal doesn't have all the attributes of a dog, right? We go back here, we say dog, dog. If our display info method only accepts a dog, we can't pass in A because technically A is supposed to be an animal. Even if we declare it as a dog, A could be a fish, A could be a mammal, A could be a cat. Therefore, this method won't work for that. It only works for dog and any of its dependents. So, since we have animal here, this method will work for animal and any of its dependents on down. So any mammals, any cats, any dogs, any fish, this method works for those. So if I say dog D equals new dog, I can call display info D. This method works for any of animals' dependents. So again, thinking back to last time when we're talking about inheritance, that relationship is critically important in object-oriented programming because we can have that general superclass and then we can manipulate it with any type of subclass that we have, all right? So if I extend, again, geometric object, geometric object is the main superclass. So I can create methods that expect a geometric object. But, you know, in the real world, we have far beyond just a general geometric object. We have rectangles, we have squares, which by extension, square would be a dependent of a rectangle, right? A type of rectangle. We have triangles. Within triangles, we can have isosceles triangles. We can have right triangles. We can have all types of different triangles. Those would be dependents, right? However, by extension, all of them would inherit geometric object. So whatever methods we create would still work for all those different types of dependents, okay? This comes in handy when you are building a system with a lot of different people. So in a corporate environment, in the workplace environment, industry environment was the word I was looking for. You may be working with hundreds of different programmers who have different types of classes, they have specific needs, and they have different classes that have specific logic and implementation requirements. But your part of it, you don't care about all those different specifics. All you care about is this a type of object? If it is, do this. I don't care if, you know, John over there added 50 more details and specifics to their object. I want my method to work for a geometric object. I don't care if they created a, you know, lopsided right triangle with 7 sides and 16 angles. I don't care what he did over there. I want my program to work for a geometric object, regardless. So I would create a method that accepts a geometric object. Okay? Is that making sense? I know that was pretty complex and a lot going on there. But if that doesn't make sense, let me know. There's a lot there.
Yeah, can you go over it again?
Yeah, no problem. So just to reiterate, again, we have, if we look at our relationship, and I'll pull up the slide, I think it was lecture 17. If we have this relationship, okay, we have animal at the top. From animal, we have fish, mammals, cats, dogs. But you know, in the real world, we have many types of animals. We have, um, what is the other type? Not a mammal, but what are crocodiles?
Amphibian.
Amphibians, or are they reptiles?
Reptiles, yeah.
So reptiles, amphibians, I believe, I think fish are amphibians, if I'm not mistaken. But you know, you said what?
Well, amphibians.
So we have many types of animals. You know, we have mammals. Within mammals, we can have elephants, we can have mice, we have all types of different animals. Underneath dog, we could even separate this further by breed. You know, we can have individual classes for different types of breeds. So there are a lot of different things that you can create and represent in programming. So with animals, for our basic example, we have an animal at the top, we have fish, we have mammals, and then from mammals, we have cats and dogs. Okay, so that's our whole representation in this program. So if you look at this diagram, what does it tell you? It tells you that whatever dog I create is a type of animal. Whatever cat I create is a type of animal. Whatever fish I create is a type of animal as well. Whatever mammal I create is a type of animal. So does that relationship make sense? Right? That's the superclass subclass relationship. Every subclass is a type of superclass, all the way up the chain. At the very top of this would be the object class. It's just the most generic type of class. It's an object. So animal inherits object, but that is by default. You don't even have to put that in your program. So if this is the relationship, another thing this tells me is that whatever animal I create is not necessarily a dog. I can create an animal that's a cat, right? Every dog is an animal, but every animal is not a dog. That's a fundamental concept in programming, especially subclass, superclass. Every subclass is a type of the superclass, but every superclass is not a type of the subclass. Again, every fish is an animal, but every animal is not a fish. Okay? So if we understand that, then if we look here, again, since every dog, every cat, every mammal, and every fish is a type of animal, I can create a basic animal object up here. Let me create it right here, actually. I can create a basic animal object. I can set or instantiate a fish, a mammal, a cat, or a dog to that animal, right? Because with the subclasses, they inherit every characteristic. So if I look at animal, what are the characteristics of an animal? At its most basic core, it has a sex, right? It has a sex, male, female, or other, right? So every animal has that sex. Well, if that's the case, if mammal inherits animal, that means by extension, every mammal has a sex as well, right? It inherits every characteristic of animal. However, mammal has a couple more attributes. Is it bipedal or quadrupedal? Either does it walk on 2 legs or does it walk on 4 legs, right? Every mammal is an animal, so every mammal has a sex. If we go further down the line, every dog is a type of a mammal. Therefore, every dog has a sex, and every dog is either bipedal or quadrupedal. Now, of course, there are other options out there, but for a mammal, it's either bipedal or quadrupedal. Plus, a dog has a breed, and whether its tail is docked. So that's the full relationship within this example. Every dog is an animal, so it has every attribute of animal, plus every dog is a mammal, so it has every attribute of mammal. Okay. So with that being said, by extension, again, if we have an animal here, every fish is an animal. So I can create a new fish object and set it equal to a generic animal superclass, right? Same thing with my methods. My method expects an animal, regardless. Whatever type of animal it is, it expects an animal. If that animal is a fish, by all means, it still works. If that animal is a dog, again, it works because a dog is a type of animal, right? This dog is a type of animal, so I can pass that in. So if I create a dog object, dog D equals new dog, I can pass that dog. I can pass that dog object to this method. It still works. Do keep in mind though, since this is technically inside this method, this is just a basic animal object. Even though I know I passed a dog, I cannot call a dog dot or animal dot set docked to true. I can't call that. Even though I know I passed a dog in, I know for a fact it's a dog. What's happening in the back end is when it gets to this method, it's converting it to an animal. And so it expects it only can use animal methods. So whatever methods are in this animal class are the only ones that can be used. So I can say animal.set or .get sex. I can do that because that's in the animal class. Okay, but I can't say animal.set docked or set breed. I can't do that because that's in the dog class. And technically, this is just an animal. Next time, we will learn how to check for what type of animal you've passed in. So we can check for if it's a dog, if it's a cat. But as of right now, the only thing this compiler knows is that this will be an animal. So I can't call any methods relating to a subclass of that animal. Again, I know that was a lot to throw at you, but again, this is a very important concept. Polymorphism is a very powerful concept that allows you to be very creative with your code. By creative, I mean I can create a general animal up here, but I can set that to any type of subclass of that animal, right? I can make it a fish, I can make it a mammal, I can make it a cat, a dog, because of polymorphism. Since every cat is a type of animal, I can do this. All right. Again, that's a lot to throw at you. If you need more clarification, shoot me an email. I'll be happy to sit down with you and figure it out.